page 264 in our World and Space book, A Ringed World. The sixth planet from the Sun is Saturn, which was named after the Roman god of farming. Saturn is the farthest planet from the Earth that was known to ancient people. It is different from most other planets and moons in the solar system. It is a ringed world surrounded by 3 flat rings. The rings of Saturn are not solid. They seem to be made up of many small bits of ice and rock that circle around Saturn, just as the moon circles around the Earth. Most scientists think these fragments may be the remains of a moon. For some reason, this moon never got pulled into the shape of a ball, as the other moons and planets did. Instead, the fragments formed into 3 rings, one inside the other around Saturn's middle. Out beyond its rings, Saturn has 10 moons. Its largest moon, called Titan, is bigger than our moon and has an atmosphere. We could not breathe Titan's atmosphere, though. It is a poisonous gas. Saturn is the second largest planet after Jupiter. It is nearly 10 times bigger than Earth. It seems to be a huge ball of gas clouds that get thicker toward the center. Big as it is, Saturn isn't as thick or heavy as a ball of water its size would be. In fact, if there were an ocean big enough to hold it, Saturn would float in the water. Saturn is about 888 million miles from the Sun. Its year is almost as long as 30 Earth years. Its day is about as long as 10 hours on Earth. The faraway worlds. Someday we may send a space vehicle to Pluto, the farthest planet. From there, the Sun is only a bright star. The 7th, 8th, and 9th planets of the Sun's family are so far away from us that we know very little about them. The 7th planet, Uranus, is about 1.8 billion miles from the Sun. It was named after the ancient sky god. It seems to be much like Saturn, a huge cloudy ball of gas and ice. A Uranus year is equal to a little more than 84 Earth years. A day on Uranus is less than 11 Earth hours. Uranus has 5 small moons and 5 hard-to-see rings. Neptune, the 8th planet, seems to be much like Uranus. It was named after the Roman god of the sea. Neptune is about 2.8 billion miles from the Sun. Its year is as long as 165 Earth years, and its day is a little less than 16 Earth hours. It has 2 moons, one quite small and one nearly as big as ours. The 9th planet, Pluto, is about 3.7 billion miles from the Sun. Seen from Pluto, the Sun is probably only a very bright star. Pluto seems to be a dark, bare, frozen place, much smaller than Earth. Its year is about 248 Earth years long. Its day is about 6 Earth days. Pluto has one tiny moon. Pluto is at the very edge of the solar system. Beyond it are trillions of miles of black, empty space. Perhaps that's why it was named after the Roman god of the dark world of the dead. The tiny planets. Just as there are giant planets in the Sun's family, Jupiter and Saturn, there are also dwarf planets. These small planets are called asteroids. Asteroids circle the Sun in a ring between Mars and Jupiter. There are thousands of them. Most are less than a mile across. Some are several hundred miles across. The largest asteroid, named Ceres, is about 480 miles wide. The larger asteroids are nearly ball-shaped, like the bigger planets. But the smaller asteroids are bumpy and jagged. They may be pieces of larger asteroids, for asteroids often bump into each other and break into smaller bits. When this happens, they are knocked out of their paths and into new ones. They become meteors that sometimes collide with other planets. Such collisions made by the craters on the Moon, Mars, and Mercury. Bits of asteroids also become the shooting stars that we see from Earth. Shooting stars. A big lump of rock and metal, a meteor, rushes through the blackness of space. For billions of years, ever since the planets were formed, it has been zipping around and around the sun. But now it is about to meet its end. The lump of rock is heading straight toward a huge blue ball, the Earth. The rocky lump hurtles through space and into the Earth's atmosphere. Almost at once, it begins to glow red hot. It is traveling at such tremendous speed that Earth's air is rubbing hard against it. This friction makes the lump of rock grow hot, just as your hands get warm when you rub them together. The rock turns from red hot to white hot. Bits of it burn up, leaving a trail of glowing gas. Seen from the surface of the Earth, the burning rock looks like a bright streak flashing across the sky. A child looks up and sees it. "Look, mother," says the child, "a shooting star." That's what a shooting star or a falling star is, a meteor from outer space that comes into Earth's atmosphere and burns up. But when a meteor comes into our atmosphere and burns, we call it a meteor. More than 200 million meteors come into Earth's atmosphere every single day. Most of them are quite small and burn up completely, but if a meteor is big enough, it may not burn up before it hits the ground. It comes smashing into the Earth, a white hot lump that slowly cools off. Then we call it a meteorite, a chunk of metal or metal mixed with rock that has come to Earth from outer space. Most meteorites burn away until very little is left of them, but some that were huge to start with still weigh many tons. And several times the Earth has been struck by enormous meteorites that dug huge craters several miles wide and hundreds of feet deep. Most meteors that strike the Earth and other planets are probably pieces of asteroids that have been knocked out of their orbits. Others are probably parts of comets. This meteorite is about 4 feet wide and weighs about 3,275 pounds. Long ago, a giant meteorite crashed into the Earth and made this crater. This crater is about 4,150 feet across and 570 feet deep. It's in Arizona, the Great Meteor Crater of Arizona. A star with a tail. That's Comet Bennett. Looks cool. Night after night, a long, shining streak hung in the sky. It looked like a big, bright star with a glowing tail. Each night it seemed to grow bigger and brighter. People were terrified. "It's the end of the world," they wailed. For thousands of years, whenever a comet appeared in the sky, people were afraid of it. Now we know that comets are just part of the sun's family. There are many billions of them going around and around the sun, just as the planets do. Sometimes a comet's path brings it close to the Earth, so that it appears as a long, glowing streak in the night sky. Most astronomers think comets are balls of frozen gas mixed with bits of rock and metal. The comet does not have a tail until it gets near the sun. Then the sun's heat melts some of the frozen gas, and the bits of rock and metal stream off into space, forming this tail. This tail glows because sunlight shines on the stream of rock and metal. A comet's icy head may be about 10 miles wide. It is surrounded by a cloud of gas as much as 1,000,000 miles wide. A comet's tail may be as much as 100 million miles long. It is, yes. Why do stars twinkle? The Sun and its family of planets, asteroids, meteors, and comets are likely tiny specks of dust floating in a gigantic ocean. The endless ocean of space also contains countless billions of other specks. The stars. Stars shine with a steady glow, just as the sun does, but they seem to twinkle. Why? Because when the light from the stars reaches our atmosphere, it gets bent several times by layers of moving air. 5 of the stars we see in the sky at night are really other planets in our solar system. They shine because they reflect sunlight, but most of the stars are other suns, like our sun, that shine with light on their own. These stars are trillions and trillions of miles away from us. The nearest star to us is so far that it takes 4 years for its light to reach us, and the light travels at a tremendous speed of 186,282 miles per second. Some stars are so far that it takes their light thousands or even millions of years to reach us. A twinkle of light that you see in the sky tonight may have been given off when dinosaurs lived on Earth. How many stars are there? We don't know exactly, but scientists believe there are billions and billions more stars than there are grains of sand on all the beaches of the world. Children sometimes wonder where stars go in the daytime. They don't go anywhere, of course. They're still there. It's just that our daytime sky is so bright we can't see the stars. Blue giants and white dwarfs. There are red and blue giants out in space, and there are white dwarfs too. Sip of water. All stars are balls of hot, glowing gas like our sun. But stars can be very different from one another. There are giant stars and dwarf stars. There are red, blue, yellow, orange, and white stars. There are bright stars and dim ones. A star, such as our sun, is a medium-sized star. Stars called giant stars may be 100 times bigger than our sun, and stars called supergiants may be 1,000 times bigger. The smallest stars are called dwarf stars. Some dwarf stars are smaller than our planet Earth. In fact, the smallest dwarf star we know of would only just about cover the continent of Asia. A star's color shows how hot it is. The hottest stars shine with brilliant blue light. White stars are next hottest. Yellow stars, such as our sun, are cooler, and red stars are the coolest of all. Red giant stars are white dwarf stars. Red giant stars and white dwarf stars are really stars that have grown old. When a yellow star, such as our sun, gets old and ready to die, it swells up and becomes a red giant star. Then it shrinks down and becomes a white dwarf. As a white dwarf, it uses up the last of its energy and dies. It becomes a cold black ball, smaller than a planet. The constellation of Orion. Long ago, people thought that groups of stars looked like pictures of creatures or objects. Each star group was named after the thing it seemed to look like. These star groups are called constellations. This constellation is Orion the Hunter. On a clear night, you may see thousands of twinkling stars. They seem to be scattered helter-skelter all over the sky. But if you look carefully, you will see that groups of stars seem to form shapes. Long ago, people found that, with a little imagination, each of these star groups looked like a picture of something. One group of stars seemed to look like a hunter with a club, holding the body of an animal he had killed. Another group of stars made a picture that was like a flying swan, with its long neck stretched out and its wings spread. Other star groups were like pictures of a crab, a bull's head, a dragon, a man shooting a bow, and many other creatures and objects. The star pictures were named after the things they looked like. By knowing the shape of each star picture and its position in the sky, sailors of long ago could find their way across the sea. If a ship were blown off course by a storm, the captain had only to look at the star pictures to find the right direction again. Today, amateur astronomers still use these star pictures, called constellations, to locate the stars they want to study. Finding constellations. Do you live in the Northern Hemisphere? Say in the United States, Great Britain, or Japan? Then, during most of the year, you will be able to see the constellations shown on the star chart on page 283. Do you live in the Southern Hemisphere, in Australia, New Zealand, or South Africa? If so, during most of the year, you will be able to see the constellations shown on the star chart on page 285. And if you live in the southern United States, Hawaii, or northern Australia, you'll sometimes be able to see some of the constellations on both star charts. On the charts, the stars in each constellation are joined together with lines to show the shape of the constellation. If you know the shape of a constellation and where to look for it in the sky, you can usually find it without much trouble. To use the charts, take this book out of doors at about 9 o'clock on a clear, moonless night. Stand where you can see as much of the sky as possible. If you live in the northern hemisphere, face north. In the southern hemisphere, face south. To see the chart, you'll need a flashlight, but cover the light with red cellophane. Otherwise, the light will dazzle your eyes and make it hard for you to see the stars when you look up at the sky. The constellations moving into a different part of the sky each month. So, the constellations move into a different part of the sky each month. What did I say? Moving? Move. So, around the outside of each chart are the names of the months. Hold the book so that the name of the right month is pointed at your chest. Then the chart will show where the constellations will be when you look up at the sky. For example, in the Northern Hemisphere in Maine, the group of stars Americans call the Big Dipper and the British call the Plough will be straight ahead of you, high in the sky. In the Southern Hemisphere in June, the constellation called Crux will be straight ahead of you, close to the horizon. On the charts, each constellation has its Latin name. Some of the names are based on what people thousands of years ago thought the constellation looked like. For example, in the Northern Hemisphere, there's a constellation called Draco. That means dragon. Ursa Major means Great Bear. Ursa Minor means Little Bear, though we usually call this constellation the Little Dipper. Cygnus means Swan, and Auriga, the Little Dipper. Cygnus means, and Auriga, the Charioteer, Aruga, what did I say? Aruga? And Aruga is a charioteer. Cepheus was a king and Cepheopia was a queen. Perseus was a storybook hero who killed a monster and saved the princess. In the southern hemisphere, there is a famous constellation called Crux, which means cross. It is better known as the Southern Cross, Triangulum. Triangulum Australe means southern triangle. Musca is fly, pavo is peacock, and grus is crane. Vela is the sail of a ship, and carina is the ship's keel or bottom. The charts also show a few of the brightest stars, such as Vega and Canopus. If you live in or near a city, you may not be able to see all of the stars or constellations because of the city lights, but you will nearly always be able to see the brightest stars and some of the constellations. Star twins. Most stars seem to come in pairs, like twins, and some even come in triplets and quadruplets. A star that's all by itself, like our sun, seems to be rather rare. More often, there are two stars circling around each other, close together. Sometimes there is a third or a fourth star circling around them. Even though these stars are twins or triplets that were probably formed at the same time, they often aren't a bit like each other. Sometimes a giant orange star is twinned with a medium-sized blue star. Sometimes a yellow star, like our sun, is matched with a white dwarf. Twin stars are so close together and so far from Earth that when we look at them, they seem to be just a single twinkling star. Only with special instruments and telescopes can we tell that there is more than one star. Exploding stars. Nearly 1,000 years ago, in the year 1054, a new star suddenly appeared in the sky. It was tremendously bright, so bright it could be seen even in daytime. For 2 years, the strange new star glowed in the sky day and night. Then it slowly began to fade away, and after a time it disappeared. Where had this bright new star come from, and what became of it? Actually, it wasn't a new star at all. It was a star that had exploded. Certain kinds of stars sometimes do explode. A white dwarf star may suddenly flare up and become much, much brighter. Such an explosion is called a nova, which means new, because it looks like a bright new star appearing in the sky, but after a time the brightness fades away. The star becomes no brighter than it was before it exploded. When a supergiant star begins to die, it too explodes, but this is a tremendous explosion that destroys the star. The explosion sends a gigantic cloud of glowing gas rushing out into space, and the once giant star suddenly becomes a little white dwarf star. This kind of explosion is called a supernova. A star that becomes a supernova may become 1,000,000,000 times brighter. It was the light of a supernova that was seen in the sky in the year 1054. Misty shapes in space. The Veil Nebula, the Great Nebula, and the Ring Nebula. A crab, a ring, a veil. These are some of the shapes taken by giant clouds of gas and dust called nebulas in space. The word nebula means mist. Most nebulas are the remains of stars that exploded long ago. A ring nebula is a shell of gas that surrounds a star and looks like a ring from a distance. Astronomers do not know what causes a ring nebula. The Milky Way. On a clear summer night, you can sometimes see a bright haze in part of the sky. This haze is called the Milky Way. It looks like a gigantic cloud of stars close together. Actually, the stars are many trillions of miles apart, but there are so many of them they look like a glowing cloud. The Milky Way is part of an even bigger cloud of stars. This star cloud is shaped like a pancake with a bulge in the middle. It contains more than 100 billion stars. This huge mass of stars is called a galaxy, the Milky Way galaxy. Our sun is one of the stars in this galaxy. The sun is far out near the pancake's edge. Because of where we are, we can see the galaxy's bulging center, the hazy, glowing cloud we call the Milky Way. Just as Earth moves around the sun and other stars move around the center of the galaxy. But the galaxy is so enormous and the sun is so far from its center that it takes the sun 200 million years to go all the way around. The glowing cloud we call the Milky Way is made up of billions of stars that are trillions of miles apart. The white line in the photograph is the track of an artificial satellite circling the Earth. Other galaxies. This is the Great Galaxy, and this is Whirlpool Galaxy. Our galaxy, the Milky Way, has more than 100 billion stars, but it is not the only such cloud of stars in space. There are at least 10 billion other galaxies, and probably more, and each of them also contain many billions of stars. This is an artist painting of a pulsar in space. Strange things in space. There are some strange things in space. There are strange things we call pulsars. Pulsars were once giant stars, but now they have shrunk down until they are much smaller than the Earth. There is as much material in one pulsar as there is in our sun, but the material is tightly squeezed together. Pulsars give off energy as ordinary stars do, but they don't give it in a steady stream. Pulsars pulse. They give off steady, even bursts of energy, like a beating heart. There are strange things we call quasars. These seem to be like huge, dim stars, tremendously far out in space, the farthest things we can see with our most powerful telescopes. Yet they aren't really dim. They are the brightest things in space. They give off as much light as many millions and millions of stars all rolled into one. Perhaps they seem to dim because they are so far away, so far that the light from some of them takes thousands of millions of years to reach us. And yet many scientists are not at all sure that quasars really are tremendously far away. In some ways, it seems as if they are much closer. Scientists are carefully studying these strange things, trying to find out what they are and where they are. Some astronomers think there are strange things in space called black holes. A black hole would be an enormous star that has shrunk down until it is squeezed together so tightly that nothing is left of it but gravity. The pull of that gravity would be so strong that nothing could get away from it, not even light. That's why these things are called black holes. Waves from space. This is a radio telescope that can locate waves from space. Right at this minute, you're being hit by bullets from outer space. Space is full of waves. These aren't the kind of waves you see on an ocean, of course. They are waves of radiation. Radiation is streams of tiny, tiny bits of atoms. These particles are so small you couldn't see them even with the most powerful microscope. They travel at tremendous speed, 186,282 miles per second. They are like little bullets. When they reach Earth, some of them go zipping right through you without you even knowing it. Radiation is given off by most things in space: stars, quasars, planets, and the huge clouds of gas and dust called nebula. Radiation comes to Earth in the form of light, heat, radio waves, and what we call X-rays, cosmic rays, and gamma rays. Earth's atmosphere shuts some of these things out. Scientists think there is also a kind of wall in our solar system that shuts out others. This is a good thing because if too many of some of these particles entered people's bodies, they could cause sickness. Even though the particles are so small that the waves are invisible, scientists have many machines that can find different kinds of radiation and tell where it comes from.